Hello, class. Welcome to our introduction to the periodic table. This is going to be a video lecture, so you can jump on and look at it anytime. If you need to go back to it, it'll be on Classroom, and so you can refer back to those things. If you need to pause it as the video is going on to ask questions, something you don't understand, make sure you do that. These videos will be in 10-minute sections, and so today during class you'll have a couple of these to watch. And it'll have places in the video for you to pause and practice some skills and make sure you're understanding things, and times for you to ask questions of teachers as well. Also, you need to have notes that you're filling in, and you should have those given to you. If you don't have those, make sure you get those before you watch the video so you can be filling in things along the way. Feel free to pause the video and take notes during those times that you need to fill in the blanks. And so we've already talked about some of this stuff. To start with, we'll have a little bit of review, but we need to make sure that you understand it, because everything we do for the next 3 weeks is going to be built on your ability to read and understand the periodic table. Well, as we introduce it, we need to look at, where did we get this periodic table? So the one you have on your table, the one you're seeing on the screen right now, where did this come from? Well, this one came from a guy named Dmitri Mendeleev. He's considered to be the father of the periodic table. There's a video that you can watch as well that's from Crash Course that you can see and get a little bit more information and understand how he came up with it. But you need to know that he's considered the father of the periodic table that we use today. He discovered that elements followed patterns that we see in the periodic table. In fact, he saw those patterns so clearly that he knew that we had not discovered some elements yet. There were blanks in his periodic table. Kind of like if you were putting together a puzzle and you were missing a piece, you would know that you were missing a piece because nothing else fit the patterns of that piece and where it was supposed to be. And so he knew that these patterns were so consistent that we were missing elements from the periodic table. Even to the point of, when someone else discovered an element, they gave some characteristics, he was able to correct them without even knowing or seeing what the element was yet, based on the periodic table and what he knew it had to have as far as its characteristics and its families and its group. So I'd encourage you, watch that Crash Course video to learn a little bit more about Dmitri Mendeleev. As we look at the atom and we look at how these things are organized in the periodic table, we need to know some information and get some review going for ourselves. The nucleus. The nucleus is the center of the atom, and it makes up the majority of the atom's mass. It contains protons and neutrons. And so when we look at things in a few minutes, like the atomic mass, this is what it's talking about. It's talking about the mass of the nucleus. The electrons are so small, they don't really factor into the mass of an atom. We look specifically at the nucleus for that. Also, when we look at an atom, we need to remember that atoms have a neutral charge. Now, atoms can become ions where they gain or lose an electron, but when we're looking at the periodic table, they're all going to have the same number of protons and electrons. And so the number of protons equals the number of electrons. Equals the number of electrons, which is a zero net charge. An example of this would be hydrogen. We see the picture right there. One proton, one electron, and so they cancel each other out for a zero net charge. There's a neutral charge for all the atoms that we're looking at on the periodic table. When we're looking at each individual block on the table, you'll see a number that's above the symbol. Now, the one on the screen has it in the corner. Some of the periodic tables that you have may have it right above the symbol, but that symbol is called that number is called the atomic number. It's the number of protons in the nucleus. Now, because the atoms that we're looking at in the periodic table are neutral, it also tells us the number of electrons in the atom. But the identity of the atom is attached to the atomic number, which is telling us the number of protons in the nucleus. If you were to change the number of protons in the nucleus of an element, you change the element. It's no longer the same atom anymore. It turns into something completely different. Now, you can change, however, the number of neutrons in an atom. Atoms with the same number of protons but different numbers of neutrons are called isotopes. Here's an example of a few different isotopes, all of the element of carbon. Carbon 11, carbon 12, carbon 13, and carbon 14 are all carbon. if you look at the number of protons in each one, you see they each have 6 protons, which means they're all the same type of element. But they all have different numbers of neutrons. And so carbon, we see here, has these 4 isotopes. Now, some of those isotopes are stable and some are unstable, or they're breaking down. So you see 11 and 14 are both unstable. 12 and 13 are stable. They stick together fairly well. But they're all the same element. They're all the same type of atom. They're just atoms with different neutrons. So you can change the number of neutrons and the element still keeps the same identity. But if you change the number of protons, it would become something completely different. So you have the atomic mass, or atomic number that's at the top, and the atomic mass that's at the bottom. And so the atomic mass, remember what we said, is the number of protons plus the number of neutrons. And so here in our example, we have 36 protons, and our atomic mass is 83. In this case, it's 83.8 because it takes into account some of those isotopes. So there's different numbers of neutrons. This is the average for this element. This is the average number of neutrons in the mass. So in this case, you would round up to 84, and then you subtract 36. So if you want to go ahead and pause this and take a minute and figure out what is 84 minus 36, and that would give you the number of neutrons that krypton has. So the atomic mass is the mass of one atom of an element. It tells us how much one atom weighs in atomic mass units. This is the atomic mass of each proton and neutron. Now, neutrons are slightly bigger, but they're so close to the same size, they're given the same weight. Each one is given a weight of 1 AMU, or atomic mass unit. And so you see the atomic mass comes from the protons and the neutrons together. The atomic number at the top is the number of protons. So if you need to know the number of neutrons, you subtract the atomic number from the atomic mass. So we're going to go ahead and do a couple of questions. This is where I want you to pause the video, pause the lecture, and answer the questions. So here's some of the questions. What particles make up an atom? What are the charges on these particles? And what particles make up the nucleus? Now, this is review, should be pretty quick and easy, but if you have questions, make sure you ask at this time. Go ahead and pause and answer these 3 questions. Here's 3 more questions for you. On your atomic or on your periodic table that you have there on your desk, look at oxygen, find where it is, and answer these questions. What is oxygen's atomic number? How many protons does oxygen have? And how many neutrons does oxygen have? If you have questions or you're not sure, make sure you're asking at this time. Well, this concludes this first video. So make sure this is a great time to ask questions. Make sure you're clear. Make sure you know what's going on. And then I want you to proceed to the next video. Make sure you filled in those blanks, filled in any information you have. If you missed something, make sure you're asking a teacher.